Okay, everyone, welcome to the September community call for Singularity CE, the open source project. This one will be mostly kind of looking at the recent Singularity CE 4.2 release, which went out yesterday, and just recapping what's in there, where to find documentation and so on. We'll look forward to what we're planning for 4.3, and we'll also have time for any discussion or questions at the end. I should mention up front that from this call onwards, we're going to change the frequency down to once a quarter, so once every 3 months. And we're going to see how it goes there with the number of people who turn up and how engagement is on GitHub through discussions, issues, and so on, or via the Slack channel to see how that goes. We could possibly return to a monthly schedule in the future, or if people are sort of happy with quarterly updates on the project in this form, then we'll communicate mostly via discussions on GitHub and in the Slack channel and so on in between. Okay, so yesterday we released SingularityCE 4.2.0. So here's the release page on GitHub. And there are a bunch of new features and bits of functionality in this release, which we've gone through and done demos of in previous calls. So if you're looking for demos, we're not going to redo those today, but if you go to the YouTube page for Sylabs, which you can find through the community call links, you'll find that in prior sessions, we've gone through and actually kind of demonstrated each of these features at length. I'm going to jump across to the Sylabs.io docs page here just to show you that the release went out yesterday and the documentation is in place for this release. So if we jump across to the documentation, what you'll actually find is rather than just looking at the release notes on GitHub, you can jump into the administrator's guide, and there will be a What's New in Singularity CE 4.2 section, which is going to call out what's new of note to administrators who are installing and configuring Singularity, and we'll see the corresponding one for users in a second. But let's go through the administrator items first. So what we have in 4.2 then are some additional directives in singularity.conf, the kind of main configuration file that allow the use of namespaces to be restricted in the native mode. So if I jump through the link here, what this means is that in previous versions, administrators could turn off allowing Singularity to create a PID namespace. So you could block people from requesting a PID namespace. In this version, 4.2, you can now block people from requesting a user namespace or a UTS namespace. And this is actually out of a request that came in on GitHub related to interactions with licensed managers. So I believe there was a site who are having problems because users were requesting user namespaces or UTS namespaces, and these were interfering with the ability of the license manager to verify that some software running in a container was licensed for the system. So they requested a way of sort of disallowing that so users couldn't request them and wouldn't be confused by that. There are some things to note here. So if you disallow user namespaces, then you can't execute containers with the user NS option, which is kind of self-explanatory, or with fake root. This really doesn't make sense for unprivileged installations of SingularityCE because they require user namespaces to run any container. It only makes sense if you're trying to lock down a standard setuid installation. The UTS namespace, what this really means is whether you can or you cannot set a host name for a container. So the UTS namespace is where you can change the host name of the container relative to the host itself. So you can disable that, which will disable the UTS and host name flags if you need to. The second item here is that there's a new flag when you run a container called netnspath. And what this is about is allowing a container to join an existing network namespace. So with Singularity, you can, as root, or if the system administrator has configured it, create a network namespace and set up a specific network configuration inside that namespace using the container network interface, the CNI tooling, which can do things like set up bridges or set up DNS, sorry, not DNS, IP masquerading and forwarding. And lots of different network things you can do there. But Singularity, as was in 4.1, couldn't join an existing network namespace other than the one it was actually run from. And this is an issue for some kinds of advanced use where on systems, sometimes multiple network namespaces are used to kind of sandbox certain types of processes into being able to access only a certain VLAN or only certain hosts. There was a request to be able to be more flexible here. So this netns path, if you have a network namespace that you want the container to join, you can specify the path to the network namespace. Root can join any network namespace. Anyone else can only join a network namespace if it's specified in Singularity Conf using some new options. So these are all explained here. It kind of piggybacks onto how we allow unprivileged users to access certain CNI configurations for creating network namespaces. We have an allow net users and allow net groups to kind of set up who's allowed to do things. And then down here, the allow net NS paths, this lets you specify which network namespaces those people can join. So this might be interesting for people who have rather complex networking setups and have kind of scripted around maybe network namespaces in job scheduler, prolog, epilogue scripts previously. The requirements for 4.2 have changed a bit more than we usually see when we have a minor release. So Go 1.22.5 or above is required to build 4.2. We usually try and track the supported Go versions, which are the current version 1.23 and the previous version, which would be 1.22, and allow Singularity to be built on those without any kind of restrictions on the final patch number, the .5 in that 1.22.5. But the way Go handles kind of version updates and has the ability to bring in new versions through its tooling has led to some of our dependencies requiring specific patch versions of 1.22. So 1.22.5 is now the oldest version of Go you can use to build Singularity CE 4.2. The OCI mode supports writable overlays, which we'll see in the user-facing what's new. That functionality requires Fuse2FS version 1.46.6 or above. Now, this is a relatively new version of Fuse2FS. It's not the default version available in most long-term distributions. The reason we aren't bundling it and building it like we do for Squash Fuse is that Fuse2FS is part of the E2FS progs, which is licensed under the GPL license, which is a copyleft license. And we are trying to keep our entire source tree under a permissive license rather than a copyleft license. So that's why it's not included here. So if you want to use this functionality in older Linux distributions, you would need to obtain Fuse2FS 146.6 or above for your system. The final point here is that CE 4.2 doesn't support Enterprise Linux 7. That's Red Hat Enterprise Linux 7 or CentOS 7. Those have gone mainstream end of life already. We've also chosen not to support SLES 12, and SLES 12 is going mainstream end of life in October next month. We're dropping SLES 12 ahead of the mainstream end of life in this case because SLES 12 is extremely restrictive with regard to the OCI mode and OCI compatibility features that we've added in 4.1 and extended in 4.2. So if you're on SLES 12, then you can essentially stick with 4.1 and the functionality you get there, you wouldn't have been able to improve on it with 4.2, even if we'd targeted SLES 12 for 4.2. Any questions on these for the admin-facing stuff? All right, I will jump across to the user guide now, and let's have a look what's new in Singularity CE 4.2 again, but from a user's perspective. I've gone to the admin guide. Whoops. There we go. Let's try again. Okay, so most of the new stuff in this release is in OCI mode, which is because our focus has been on increasing compatibility with OCI tooling and for people who are working, say, primarily in the OCI realm, but then maybe just taking containers and using them with Singularity only for deployment on HPC. We want to support those types of workflows. So the first bullet point here is actually about going back the other way. To date, with Singularity, you've been able to take a Docker container, an OCI container, and get it into a CIF file and then run it with Singularity. But if you've created a container with Singularity or you've pulled something down and you want to push it back out for use with an OCI runtime that isn't Singularity, you haven't been able to do that. What you can now do is Singularity push with a flag which is called layer format and give it the value tar. And in OCI mode, if you have an OCI CIF image that you've either pulled from somewhere or you've built in OCI mode, if you use this layer format tar flag, you're actually going to push the image up into an OCI registry in a format that's compatible with other OCI runtimes like Docker and Podman and so on. So if we go through to the documentation, there's some detail here, but down in the example, you can see that I pushed up my Singularity OCI CIF container into, in this case, the SCS library. And I can then use Docker, I can authenticate, and then I can actually directly run with Docker this container from the Sylabs SES library here, because it was pushed up in a sort of Docker OCI compatible format. So you can now go both ways, bring OCI containers down and push things back up as a true OCI container for use with other tools. Any questions on that bit? All right, moving on. The next big chunk is that we have the ability to use persistent overlays in OCI CIF files. So for a long time, we've been able to build a container into a CIF file in Singularity's default native mode, and then add a writable area into the CIF file so we can make changes to the container, and those changes are persisted inside the same CIF file that holds the original container image. So it makes a kind of read-only container into a read-write container, really. This hasn't been possible until now in the OCI mode, and the reason for that is that in OCI mode, we are storing in an OCI CIF file the container image using structures which conform to the OCI specifications. And these are really all about read-only container images consisting of read-only layers. So what we've done now is we've developed and worked up a way to kind of put an overlay into an OCI CIF file, which really kind of emulates the behavior of the old native mode. So you have now a read-write container, but can also fit in with OCI flows where we expect containers to really be read-only. And the way that we kind of do this is we have the ability for you to add an overlay into a container, and then you can, in the second example, we can actually write into the container then. What happens behind the scenes is that we add a layer to the container image in the OCI CIF, which is an ext3 file system. And only Singularity understands that. So Docker or Podman or other runtimes, they wouldn't understand what that is. But we additionally have a kind of synchronization so we can, when it's required, synchronize the digest of that overlay, that writable portion, with the container's manifest, which is an OCI structure that's assuming basically that containers are read-only, so that when we go to push something up into an OCI registry, we kind of update the manifest, the kind of descriptive structures about the container before we push it up, so that everything is consistent at the point a container with a writable overlay is pushed up into a registry to share. So you can push and pull images with overlays. The documentation here gives a bit more detail about how that works with squashing or preserving layers. But down at the bottom is the piece which is sort of new for these OCI CIF overlays. And that's the fact that there's a new command called overlay seal. And what this does is if you've put a persistent overlay into an OCI CIF file, an OCI CIF container image, and you've made some changes, you can then make those changes permanent by sealing the image. And what sealing the image does is it converts the overlay, which is a writable ext3 format layer, into a standard read-only layer. And that then brings us back to a point where we could, if we want, then push up the image into a registry with the tar layer format we looked at before, and it's usable with other OCI tooling which doesn't understand the concept of a writable layer. So there's a flow here which allows you to add an overlay, modify an image, and sort of finalize and seal your changes if you want to then either kind of deploy that to production or share it for use with other OCI runtimes. Any questions on the overlay portion? Okay. We've also previously looked at data containers. So data containers in OCI mode are a new feature where we have a new command which allows you to package data into an OCI CIF file, which isn't a container image. It doesn't hold an application. It's not an application container, rather. It's instead just a data container. You can't run it on its own, but you can put data essentially into the same OCI CIF image format that you can push up into an OCI registry in order that data can be shared alongside application containers. And there's some overview here. Basically, say you've got some kind of genome sequencing software and it requires different reference data for human, mouse, rat, zebrafish genomes. You could ask people to go and get the reference data separately and use it with your container, but that's kind of awkward for them. You could try and package all of the genome reference data alongside the application in a single container. But that's going to give you an enormous container, which has a load of redundant data for people who are only doing analysis of, say, mouse genomic data. So with the data container feature, what you can do is you can now package up each reference data set, so each different genome's reference data into a separate data container, and you can push those data containers up, share them via an OCI registry. So they're directly alongside the actual application you're sharing in the container. And then they can be pulled by a user and actually used with that application very straightforwardly. It's kind of keeping everything in the same flow, your reference data and your application together. So the documentation here basically goes through what was demonstrated in a previous call a couple of months ago, where we simply used data package to create a data container and we put stuff inside. And then there's a flag called data, which just maps from the data container, mounts everything in the data container at a specified place within the application container that you're running. So this is really kind of a shortcut round some of the syntax of the bind mount flag, which previously allowed you to mount things from arbitrary file system images. This is kind of a short form of this specifically for data containers. And as I mentioned, we can quite straightforwardly push a data container up to the SCS library, or we can push a data container to Docker Hub or another OCI registry after authenticating. So it makes it very easy to share reference data alongside your applications. Any questions on that? Any thoughts on data containers? All right, this runtime portion here, then we talked about on the admin side, the netns path to join a network namespace. The only other thing at the bottom here is a change which was pulled in from Aptainer. So you can now start an instance with Singularity instance run, in which case the instance won't execute the start script from its definition file, but it will execute the run script. So this is useful if you have a container, you want to run it as an instance, but the creator of the container didn't anticipate that it would be used as an instance, so they didn't create a start script. Or if you pull a container from an OCI source like Docker Hub and so on, and you want to use it as an instance, well, the entry point and CMD behavior of the Docker container is transferred to the run script. So instance run allows you to access that default behavior of the container. All right, so I think that's a kind of fairly lengthy run through the bullet points on the release. That's what we have for now for 4.2. If anyone has any questions, please raise your hand. Otherwise, we'll jump forward and have a quick look forward to 4.3 and where we're going next. Oh, there's a question here. I see. Yeah, Nathan, do you want to ask it out loud or shall I just read out from the chat?
Yeah, I guess just basically my question was, does any of this functionality concerning OCI mode support, OCI CIF, does that work on systems that don't have the etc sub-UID and sub-GID mappings, or is that possible in the future?
At present, no, it's not possible. We did think about this. So there's kind of a caveat, right? That if you allow it to be run on systems without sub-UID or sub-GID mappings, then you compromise the compatibility with basically the OCI specifications, because the OCI specifications require that we be able to enter the container as a specific user or user ID. So we did discuss this at length in the 4.1 cycle, and we decided to keep it that the OCR mode would only work with sub-UID, sub-GID mapping. So it was a more sort of proper, more correct OCI mode. But we could kind of consider looking at that in the future. But I guess what we would possibly do if many people want that is make it available for an admin to turn on so you can get some functionality without those mappings, because it does honestly compromise the compatibility to a fair degree whenever you come across a container which has a user declaration in the Docker file or similar.
It makes sense. Thanks.
Dave, you've got your hand up.
Yeah, I could comment a little bit more on that, and then I have another comment to make. So, yeah, from my understanding, the OCI standard requires at minimum 2 user IDs, which you can't do without the sub-UID mapping. It's just like it expects to have a root and an unprivileged user pretty much all the time. So, yeah, it would be quite a incompatibility issue. So I don't know if you wanted to say anything more about that, Dave. Otherwise, I have another topic.
I mean, yeah, essentially, if you're running a container which is only using root, you can kind of fudge around it. But as soon as you have a container which requires a specific user unprivileged inside the container, then yes, you hit that situation.
Right. Okay. So on another topic, you were saying you didn't want to include any like Fuse 2FS because of GPL restrictions. What we do in Aptainer, I don't know if you'd notice it, is just have a script. We don't include any of the source code for those embedded things. It's just a script. So I don't see any restrictions except on the binary we create. But as far as source restrictions go, you have a script that downloads the source code, another script that compiles them, and another one that installs them, another one that cleans them up. So we can run that from the packaging command script and for both for Debian and RPM. And so I don't think there's any restrictions we just don't include the source code directly in our source code.
Yeah, so We kind of looked at that. So one of the things that we particularly want to do is be able to build without an internet connection at all.
Right.
So
Yeah.
therefore, yeah,
It
having
does
a
that too. I mean, that's why we have the download. The download script gets done at the time we generate the like the source package, the source RPM, and then you can then right. So that's why there's separate scripts. So the download. So now now we've included that when we're doing the build. Not it's still not part of the obtainer source code at all. It's just it's part of the. I guess it's a distribution of the source at that point. Yeah.
Yeah, I mean it's a little bit complex. I mean we've seen what Aptainer does, and at this point we've decided not to include
Okay.
it, but it is something that we'll try and make it more possible in the future. So for example, the OCI mode requires SquashFS tools of a certain version or SquashFS tools NG. And what we've actually done as Sylabs is work to package SquashFS tools NG in Apple when it wasn't available, so people can
Mm-hmm.
access it that way more easily.
Yeah.
So
I've done that.
yeah, we're looking at this, but at this point, that's there. It's a restriction on the embedded overlays in OCI CIF files at this point, but we'll look to smooth that over in future. So thanks for the comments. All right, then let's jump across to think for the future then. So Singularity CE 4.3. This is what we have up on the board at the moment. So we're going to be looking at integration with SigStore. So basically in the broader OCI world, the SigStore product has kind of emerged as really promising the dominant solution for OCI container signing and verification. And there's a tool called CoSign, which is out there for signing containers and other things from the SigStore project. This is basically something that's an alternative method potentially for OCI CIF signing versus our Singularity Sign and Singularity Verify, which currently use PGP keys or a PEM key with some certificate support in there as well. So the plan is to look at SigStore and basically have OCI CIF signing in a manner which is basically the same kind of flow that's being used, the same structures and things as for cosign being used with OCI containers directly. The second point we have is to improve integration with the tooling from Anchor. So Anchor are a company who spearhead two open source projects, Sift and Gripe, which are of a lot of interest because they are there to create software bill of materials for what's inside a container and to audit these SBOMs versus published vulnerability databases. And we previously worked, or mostly Adam on the call has previously worked with Anchor to add support for scanning the native mode CIF files with the Sift and Gripe tools. We can't currently scan OCI CIF files with Sift and Gripe directly, although saying that with 4.2, what you can actually do is push them somewhere with layer format tar, and then you could use Sift and Gripe against that kind of remote image in a registry. But what we're going to try and do is contribute support to the Anchor open source projects to be able to scan OCI CIF files directly locally, and also be able to scan things located in a remote registry in the kind of Singularity specific layer formats and so on. The third point then is to improve, document, and test better the behavior when you're nesting containers. So people quite often these days run Singularity inside of Docker or Singularity inside of Singularity. Often that's because there's some kind of CI/CD pipeline which is being used to build containers, and the pipeline executors are containerized. So you're always inside a container when you're running those pipelines. And there are certain things you need to be able to nest containers, capabilities, and the ability to execute certain system calls. And also, a container runtime has to watch out for certain things when it's looking at the environment. It might have to be aware that it's nested at certain points in order to correctly pull the right UIDs and so on. And Singularity has kind of tried to support nested execution, but this has really been quite informally tracked to date. There's no automated testing of nested execution, and we do have issues arise where changes have been made to code and the effect on nested execution wasn't tested or considered, so you have some problems there and things regress for a time. So for 4.3, we want to have some testing for nested workflows, and to go through and basically catalog any blocking issues, trying to address them, and have more documentation as well on what you need to do to be able to run containers nested. The final point here is really a technical one. There's an issue with the Go garbage collector and file handles and how Singularity and actually other runtimes as well, how they close file handles in the process of starting a container. And we use a particularly kind of blunt but effective method to address the issue. Aptainer has solved the approach kind of in a few different pieces. And also RunC has yet another approach to try and avoid closing file descriptors that Go needs to stay open. So what we're aiming to do in 4.3 is just to move from the blunt but effective method to something a bit more clever, looking at what other projects are doing and basically coming to the best solution for us there. So that's what's planned. This point down here isn't necessarily planned for inclusion unless various people are interested in it. This one is to be able to, when you try and bind something in during a build, to make the target of the bind available, sort of created in the build automatically. It's more complex than it seems to do this because of the structure of the code. So that's where we're going. Anyone have any questions on that roadmap? Okay. So as I mentioned at the start, these calls will be getting a bit further apart. We're going down to quarterly. What we've kind of seen is that the attendance in person isn't huge. We get quite a lot more people watching on YouTube, but we want to just experiment going down to quarterly, giving sort of bigger updates each quarter, and interacting a bit more of our GitHub discussions and in the Slack channel instead, to see if we can kind of drive a bit more engagement, get a bit more feedback there, where it might be easier for people to do it asynchronously than turn up to the call, which is scheduled on the first Thursday each month. So we're going to try this for a bit, but we'll review it and we'll see how it goes. Any general questions? Anything anyone wants to discuss or ask before we finish? Okay, then. We'll send out the link to the recording on YouTube. and obviously update about the next meeting, going onto the quarterly schedule, but we hope to see you then. If you do have any questions about the release or the other stuff in this call, feel free to post them on GitHub in the discussion, ask on the Slack channel or on the Google group, and we'll see you next time.
Thanks.